So if anyone misses this, they'll be able to join it. So Steve, thank you for joining us for our first session of Stormwater Awareness Week, and I'm going to hand it off to you.
All right, John, I appreciate it. And thank you for the opportunity to present here today. I appreciate it. And I'm doing this from Portland, Oregon, which is my home office. So my business, WATERTECTONICS, we do industrial stormwater treatment systems throughout the West Coast of the US. The origins of our business were in Washington State, but we since really expanded into Oregon as well as California. And in honor of Stormwater Awareness Week, the Portland weather gods have honored us with a nice rainy day here. So very fitting. Anyways, let me get my presentation up. Host disabled participant screen sharing. I need to let John know that.
Try it again, Steve. And all the commotion, okay. I forgot to make you a co-host. You should be able to do it now. Sorry about that.
All right, no worries. Okay, does everybody see my PowerPoint there?
Yes, go ahead and put it in presentation mode.
Okay, let me get that. Presentation mode. Okay, is that working?
Yes, great.
All right, awesome. Awesome. So yeah, let me kick it off here. So the title I came up with here is uh-oh, I'm over my permit limits, now what? So basically just kind of tell you the story and the process to go through if you are over your industrial stormwater limits. This is focused around California, but really would be applicable to anywhere that your stormwater runoff is regulated, that you're exceeding whatever the benchmarks are, and then you therefore have to do a treatment approach. So let me step into it here. So kind of a three-step process here. If you're in that situation, right? First is determine the optimal treatment approach for your site, really life cycle cost of all the different options, right, is a pretty typical way to make a comparison, as well as the risk, right? Certain solutions might be less expensive, but the risk of exceedance could be higher. So there's a process to scientifically compare those and assess those. Step two then is once you figure out the right treatment approach, then it's obviously, how do I deliver the treatment system itself? There's a couple of different ways to do that I'll talk about. Each has a different risk profile, different sort of in-house time commitment versus what you outsource to other experts that can help you through this process. Third step then is really, finalize the details for your site, figure out the right configuration, the right integration, the right control system details, get that up and running at your site. And, all along the way, right, learn from others, okay? That's kind of the purpose of today's presentation is I'll show you a handful of sites, what their issue was and how they navigated the different choices they made to get their system up and running. Another great presentation on Tuesday at 11:15 a.m. Similar subject matter. My colleague TJ is going to be doing that one. And it's really the top 5 pitfalls to avoid. So again, just learning from other sites that have been through this journey and figuring out, what can I learn from, what can I apply to my site. So first of all, right, the assumption here is that you're generally aware of what stormwater is, what the permits are, how that all works, and so you've kind of started to go through this process. You discharge stormwater, yes. You're subject to the IGP, yes. Okay, then you may need to treat, depends on where you're at with your permit limits. There's an extra layer of complexity that certain water bodies in California have what's called the TMDL, which is a limitation on each individual pollutant that's allowed to be discharged to that water body. That's then allocated to each site. And so if you're on one of those, ultimately you need to study where you discharge to. If you're on one of those water bodies, then you also have to consider this. There's 36 of these in California. 9 of these only have one pollutant, but some have up to 8. So, depending on what you're up against there, right, that's going to affect the complexity of your treatment solution. Typically with complexity comes costs, with that comes risk. So think about this scientifically, figure out what is the right solution for my site. And of course, that includes if you actually have those pollutants, right? You could have a TMDL, but not actually have that pollutant on your site. So the assumption here is you've basically navigated that process. Okay, this is what I'm discharging. This is the limits of those things. Now I need to come up with a treatment solution. So that's the crux of what I'll talk about here today. So, it's really basic stormwater 101, right? The rain comes down, it's, mobilizes these particles to a discharge point. Those are over the discharge limit, therefore you have to treat. You can certainly try to cover parts of your site, typically not feasible or cost effective for larger sites. But worth looking at, certain processes that might deliver the pollutants could be covered to prevent that going to the stormwater, right? That could avoid a treatment system. Just things to think about there. And then once you're looking at treatment, really there's 4 categories, right? Gravity, those particles can settle over time. Filtration is a physical barrier, a scientifically constructed, manufactured system that will filter these particles that have the pollutants. Then some pollutants, though, are going to be dissolved, so they're not going to be removed with the particles. Then you've got a couple choices, right? Absorption, which is more of a natural process, bioswales, things like that. Then you have adsorption, which is, a natural process that's basically through a manufactured media that has a certain capacity to absorb certain types of pollutants. So this is kind of your suite of options here. The biggest challenge with gravity is, as particles get smaller and smaller, their settling time really gets longer and longer to the point where it's no longer feasible for a site to remove these via gravity. Then you have to get into a more of an active manufactured treatment approach. Great example here, right? A couple inches over 24 hours. That very big tank you can picture, 40-foot diameter, 30 feet tall, 10 micron material. If that's all you had in there, it would take 6 days for that material to settle so that water could then flow off the site without that contamination in it. Really not really feasible, right? That would take a huge site. Tanks are expensive. Real estate, especially in California, is pretty finite. So this is where we get into this active treatment system. But there are, other approaches, right? We have the settling basin. If you do have larger particles, infrequent rain, things like that, that can work. You've got the passive BMPs, best management practices. So using that natural absorption, source control, right? Silt fencing, things like that. There's always reuse, right? You can capture or treat that stormwater, use it for another purpose within your process. Just keep that on your site recirculating. Then infiltration, right, is sort of the on-site compliance approach. Takes a lot of real estate, right? Takes a certain soil profile that allows that volume of water to run off. If that's not possible, then you sort of end up at this active treatment approach. Unless, certain sites, there's the ability to talk to your sanitary sewer provider, and perhaps you could discharge stormwater to the sanitary sewer. They would have a separate pre-treatment requirements for that. So, worth investigating, but typically we find that's pretty rare that that's allowable, but there are instances where it is. So always worth consideration and compare those costs. And then ultimately you arrive at active treatment. So using water treatment technologies in a series, right, a multi-barrier approach in a manner that removes your solids, removes your contaminants. The risk of exceedance is very, very low because it is multi-barrier. It's designed specifically for your site. But the trade-off typically, right, is that the cost is higher. And so this is, again, where the process of getting to the right solution for your site is a comparison of life cycle cost to risk of exceedance. Okay. And so I'll talk a little bit about how to go through that process. Really, there's probably, finer permutations of this, but I kind of put it in two different buckets. There's the consultant-led approach. Let's call it the design bid build versus a direct procurement, which is more of a design build. So let's talk about those. Design bid build, it would be, you're at a site, you already have a certain workload, you feel that you don't have the bandwidth to take this on yourself. And so a big advantage is you could hire a consultant that would essentially take you through this process to scientifically analyze what is the right solution for my site, what are the trade-offs of the different potential solutions. They could lead you through the procurement process, create bid documents, bringing multiple competitors together to compare what's the right approach there. Where does this work great is when, the treatment solution is fairly well known, pretty proven, lower risk. You get that competitive bidding. You're comparing very similar treatment approaches side by side. So you can really ferret out who has the right technical approach, who has competitive pricing, who can help me start up the system, who has a good control system that I can monitor remotely, right? Really comparing directly. Disadvantages, right? It has to be specified very well. Otherwise, you could have a couple different vendors saying, yeah, this is apples to apples, but their systems may not actually be equivalent. And so a good consultant is going to figure out how to specify a minimum service quality, minimum technology quality, et cetera, to make sure you're comparing directly. The cost of procurement is going to be higher because you are paying a consultant by the hour to run this, but you can get that greater competitiveness side by side with a couple or more vendors. So that can actually help decrease the cost of the system. So potential trade-off there. In risk, typically, right, the consultant is either going to write the specification and in doing so, sort of takes ownership of that risk because the vendors bid to that. Or, the owner ultimately keeps that risk. If it doesn't work, they're on the hook to change the system, add to the system, right, to get it to work. The direct procurement approach, let's call that the design build. That's really engaging with a treatment system provider that has the capabilities to test the water and translate the results of their treatability testing into a design process and ultimately delivering a treatment system to the site, helping with startup, transferring that system over to the on-site operators, providing ongoing support as needed, or even potentially contract operating it if your site doesn't have the bandwidth to do so. And it can also be a team, right? So it could be a team of a consultant that works directly with a treatment provider. You could have design build teams competing for a solution, or you could just engage a consultant that says, hey, this is a vendor we know provides good systems. This is how we manage to make sure we get fair pricing based on history of working with that vendor. Different approaches there. So what are the advantages there? Everybody's stormwater is like the beautiful and unique snowflake, right? Each one is different because each site is different. Industries are so unique. You've got different soils, et cetera. And so taking this approach can really help you get the very specific treatment solution, the size of that, the right barriers, the right sizing of those barriers for that treatment. Really, therefore, enables that technology innovation. The lower procurement costs, again, you're not paying a consultant to run the procurement. You're basically engaging one or more treatment system providers and comparing those on their technical merits as well as their financial merits, considering risk and considering costs, and going with the best solution. Transfers that risk effectively then to that treatment provider because they're saying, yes, I can treat this, meet those benchmarks. If that doesn't happen, they have to adjust or upgrade the system accordingly. But the disadvantage then is, you're going to get unique technological solutions that may not be directly comparable. And you have to go through that process to vet those out. That can be time consuming and there's always a decision point there. If your workload is already heavy, right, you're then taking on this treatment implementation. So there's a lot of work there. And possibly you've never done that before. And so you've got to go through this learning curve, right? From like, I've never implemented a treatment system for stormwater to now I'm doing that and I'm going through that process. But with good partners, right, it's navigable. So this is just sort of like that value chain of what a project delivery looks like. At the very beginning, right, you have to take your stormwater on a day like this, right, get a sample of that, get that to a laboratory. They have the miniature versions of the treatment equipment that they use to test that water to determine the optimal process, translate that into a design, right, size the equipment. Then you're building that, you're taking that to the site, you're starting it up, and then you're training operators, or potentially, again, if you don't have that ability on site, you can look to a vendor that can actually contract operate that for you. Okay, so then, once you've figured out, all right, how am I going to deliver the project? Then it's which treatment equipment is appropriate for the site. There's kind of a laundry list of the different things that could work here. Typically in industrial stormwater, you're using either an electrocoagulation approach or a chemical coagulation approach, which basically binds those small particles that are running off together so that those can settle out through a clarification process, typically starting with either gravity separation for the larger particulates, or if there's a limited footprint, or you have material that settles more slowly, using an enhanced settling device, such as a slant plate clarifier. Then you're going to run that through typically a media filtration approach. A few unique sites, we'll look at one later, they use UF membranes. Sometimes you can use a disposable filter, but there's a environmental footprint issue there, as well as the OpEx cost. So typically media is the best solution for industrial stormwater. It's back flushable, lasts a long time. And then, sometimes that's adequate, right? Sometimes you meet your permit with that treatment approach, but other times you need more. You need that absorption step. So granular activated carbon or ion exchange resins are very commonly used in stormwater. Those have the ability to absorb a certain amount of pollutants over time and hold those. Ultimately, those have to be regenerated or replaced, but that's typically quite a long life in stormwater. Once that treatment system is known, then the next question is, how do I get it on my site, get it up and running? Typically there's three approaches. There's a mobile solution, right? So it's something that you can actually drive. It's in a trailer of some sort. You can drive that to the site if it's a temporary need for some reason. That's a great fit. Containerized, it's got the whole HVAC system. These treatment technologies generate a lot of heat with the electrical controls that run pumps and mixers and things like that. And so that has to be cooled so that those operate effectively. and consistently. Or if your site has some covered area or some interior area, the skidded approach is logical. The idea is that your treatment system provider, much like if you purchase a manufactured home, they build the system at their site. The only thing that's left at your site is just to plumb things together, make electrical connections and liquid connections, because that specialized labor and a very, sort of efficient process, much like an assembly line, is utilized to build that system at that provider's site. So just a quick, pros and cons, best for with those approaches. The first couple can be temporary. The containerized could be temporary or permanent. Those have the integrated HVAC. Really, outdoor for containerized. Mobile could be indoor or outdoor. The skidded is typically either under a cover to protect that equipment, or it's interior to an existing HVAC controlled space that you have. The beauty of the mobile, right? No special equipment. The other two, you're going to need a crane, maybe forklift, things to get that in sight. But again, most of that typical construction effort has been taken care of by, kitting these up as a containerized or a skidded or a mobile solution. Okay. Last but not least here, think about the controls integration, right? This is now a system with some complexity that's at your site. For your permit to be met, you have to have it up and running, consistently treating the way it's supposed to, so that you don't have any exceedances. So think about then, what is the upper left here, the HMI, the human machine interface, right? Is that a touch screen? Is it easy to understand? And then on top of that, right, when I'm not at the site, or if I have multiple sites and I work in a different location, how do I get notifications of what's happening there? How do I track my key performance indicators? Things like that. So just final thought there to be aware of. Okay, so now the fun thing, right, is 9 sites that got it done, going back to the title of the presentation here today. And so this is a site that was in Rancho Cordova area, a auto dismantler. And so they had actually, years before this, they had put in place an oil water separator, followed by a media filtration approach that, made things better, but unfortunately wasn't meeting the permits effectively and consistently. And so they had a bit of time here because they had something in place. They knew they had to upgrade it. And so they worked through a process. Bear with me a second, just having a little PowerPoint issue. Okay, there we go. So this was a corporate customer that had multiple sites. Sharina was the regional environmental manager there. So she had a confidence with the treatment system provider based on some success at other sites. And so this was really a direct engagement to do a treatability study. And so you can see these beakers at the lower right, sort of show the raw water, the initial treatments after the sedimentation process. And then there was a GAC, granular activated carbon absorption step to meet those discharge regulations. So this is really a turnkey: design, build, startup, train the operator, and get that up and running. To give a sense of timing, we were contacted about February, said, hey, let's do a treatability study, work through that process, leading that into design. About May, we started the installation process and really had the system up and running by September, right? Just in time for the rainy season. Pretty typical time frame approach there. And has been a very successful site. So let's take a quick look here. at those treatment performance metrics. So you can see, the suspended solids, could be quite high at this site, close to 600. The initial system that was in place was actually effective for the permit, but it was close. There's some risk there. And so this upgraded system with coagulation plus granular activated carbon really gets that TSS very, very low. Other things that were close to the permit, right? You can see the copper there. Again, with that first system, they were beating it, but the risk of that being a little bit close wasn't a comfort level for the industrial user. And so this upgrade really boosted that risk profile there. Same thing with zinc, right? Zinc was a bit close, so this was an upgrade that was effective. Okay, another example here. This is a sort of a corporate multi-sites type business. Had some familiarity with our business from success elsewhere. And so, basically did a direct engagement, but they utilized a consultant just because it's a very large sites, a lot of complexity, a lot of engineering details to figure out that the workload would have been pretty cumbersome, right, to do in-house. And so a consultant was engaged, and this was basically a teamed agreement where we worked directly with the consultant to do a treatability study that ultimately led to the selection of the best treatment system with the best risk profile for the best life cycle cost. One of the really interesting things here is that the system is permitted to discharge to the bay. This is the San Francisco Bay Area, but they also have the permission to discharge to the sanitary sewer. And so the system was designed for the bay discharge around copper, which was the tightest limit there, and a higher flow rate, about a 600 GPM. And then for the sanitary sewer, the threshold was actually PCBs, and the flow rate limit was 100 gallons per minute. And so the decision here was to continue to utilize the sanitary discharge as much as possible, but in case there was ever a challenge with that they could then go to the bay. And so to sort of, balance out that 600 GPM versus that 100 GPM, they use two very large tanks, about 1 million gallons of storage that attenuates that rainfall event so that they can discharge it slowly over time. And so this site has been very successful, right? They've met those discharge limits very consistently, have continued to go to the sanitary sewer, but they do have that ability to go to the bay when and if they ever have to. And you can see these orange lines, right, are quite a bit higher than what the system accomplishes. And so it's proven to be a very, very effective site. Okay. Moving on here, this is something that's more in the news these days. Pardon me, just grabbing some water there. Is PFAS contamination. So this was a oil terminal that actually had a fire event, right? They had a fire breakout. The good news there was that was put out, without any major damages or challenges. The flip side of that, though, is that some firefighting foam was utilized that was, had a lot of content of PFAS compounds. And so then after that event, the stormwater was monitored, and of course, the PFAS levels were quite high. And so this customer had to, get engaged with a treatment provider to, figure out how to meet that limitation on those compounds. And so again, this was a larger site, sort of a corporate environmental manager that led this process. They initially had to capture all their stormwater and actually hold that offsite to a approved facility that could then treat and dispose of that. Very high cost there, over $1 million a year. And so the need here was to do a fast implementation. Basically picked a design, build, operate approach because there wasn't the type of operators on site for this kind of complex system. And so they, through a consultant, right, worked together to find a design, build, operate provider. And we were able to do that. We did a treatability study. There was quite a variety of the PFAS compounds. So really determined that ultimately absorption would be the right solution here. Because of the broadness of those PFAS compounds, not just activated carbon, but also ion exchange had to be utilized to grab all of those. Of course, when you're operating those, potentially very high OpEx, you need to pre-treat those. And so a ultrafiltration membrane system was utilized to protect those. There was a comparison to a couple of vendors here. Basically, there was two different approaches. One was a lower CapEx, a higher OpEx approach using disposable filtration that would have had, a higher replacement rate, a big environmental footprint, versus a UF filter, which is, back flushable, higher CapEx, but really protects those absorption stages. And so that was the preferred approach, right? It was higher CapEx, lower OpEx. The UF backwash water actually is hauled off site, so there is an expense there. But now there's an upgrade happening that will actually treat that backflush water to concentrate that waste even more, repurpose some of that back to the front of the treatment process so that there's less of the volume of waste that has to be hauled off site, just to improve that life cycle cost equation. And yeah, this is going into its second year of operation. Way less than that cost initially of hauling all the stormwater off sites, meeting all those PFAS targets. So great outcome for this customer. And you can see, significant reductions of the PFAS compounds. All right, so this project was interesting one. It was a large battery manufacturer. Their process was completely indoors where they manufacture these batteries. But through the air releases from that building, they did have a filter system, but some small particulate lead would essentially escape that. And then it would, be picked up by the stormwater runoff, moved to a dissolve phase. And so then it had to be treated, brought back into a particulate phase and removed from the stormwater. This was a competitive bid, which was run by a consultant, Jackie, and there was a downspout filter system that was tried first, right? It was lower cost, but potentially higher risk. Didn't end up working. It reduced the lead, but it didn't reduce it enough. And so we had to develop a more active treatment system. So the chemical precipitation was utilized again to bring that dissolved lead into solution. And then that was going through a sedimentation process and filtered out. One of the unique things about this site was that the treatment system, you can see this lower right photo, it takes up some space. And the manufacturer, if they had put that down on the pavement there was basically a mitigation of a parking requirement that would have been necessary. And so they determined that they could basically have this temporary solution on a trailer that would avoid having to do that mitigation. Then the other issue that was really unique here is that, there are some tanks utilized for the sedimentation factor of this treatment system. You can see that in the upper right. Those would more ideally be placed next to this trailer you see in the lower right photo. But unfortunately, the height of those adjacent to the fence would have required a different mitigation. Essentially, the tanks would have had to have been painted, in some sort of artistic fashion because of the site location and the zoning requirements. And so the system actually pumps to the tanks at a different part of the site, and then it pumps back for the final treatments. So the water is moving around, but the process is the same. And so it just kind of shows when you get these constrained sites, right? Some unique challenges here, a great opportunity to engage a consultant because you're going to have a lot of trade-offs to compare on life cycle costs. A lot of creativity is going to be needed to figure out the right solution. So ultimately, this has been a very successful site. This gives you a sense of the water on the left, right, looks very clear, but there is actually a lot of dissolved lead in there. So a specific chemical coagulant is used, pH change, right, to bring that into a particulate stage and then coagulate that together. Goes through a sedimentation process, settles out, and then you've got that that final filtration stage that takes that that lead content to a non-detect level. Here we have a quarry, right? There's actually two different systems that were implemented here. The unique thing was that, you know, putting all the water through a single system would have been very difficult due to the topography of the site and just the absolute scale of the system. It was, the desire was to bring it online quickly because they had a turbidity exceedance. The site was just turbidity. So the beauty here is that, you know, basically a coagulation and sedimentation filtration process is all that was necessary. And yeah, two different systems were implemented. This was a direct procurement. So the client basically talked to two different vendors, looked at their technical solutions, actually went with the higher cost solution because the risk mitigation, the technical expectation was higher with one approach versus the other. And so the client felt that this is a low risk approach. This has been proven through a treatability study as well as a lot of experience with similar sites. And so the confidence level and the risk mitigation was much higher with one vendor. The other challenge here at this site is that it's in a mountainous area, lots of poor cell reception, et cetera. And so there was a unique control solution that was utilized with some hardwired internet, so that from the office of this industry, this business, they can track these two different systems without having to actually go to the site physically. Another interesting thing here is that the need to do this system sort of came up after the rainy season. And so we were able to basically create a stormwater sample just by using some of the particulates from the site and basically manufactured a similar runoff to what would be expected. That was utilized in our lab to come up with the right treatment solution that we could then, you know, upsize to a full-scale approach. So those two sites have been effective since those came online. And then here, this was a landfill. This is down in the San Diego area. This is owned by the city of San Diego. The environmental manager there, Luke, had to figure out a solution here to treat this stormwater. So this was a consultant-driven project. They ran an RFP to a few different vendors. The vendors responded. The initial approach here was going to be a pump and treat type solution, which, like we've showed in these other sites today. The treatability was completed. There was a design completed. The different vendors, you know, said, hey, this is the scope of a pump and treat solution. There was, you know, some good competition there, some different options, but unfortunately they were all very expensive and, you know, very onerous, right, to operate. This was a site that didn't really have electricity. So electricity would have had to been run to the site, a lot of other challenges like that. And so the consultant brought it back to the drawing boards and said, hey, what else can we do here? figured out that there's an existing runoff channel, sedimentation basin. And so if the treatment of the water happened at the beginning of the channel, the geometry of the channel would sort of create a natural mixing, flocculation process, so that by the time the water got to this the settling basin that existed, that it could settle out and use that basically as that sedimentation process tank. It was naturally already there. And so then there was this challenge of not having power at the site. And so we devised a solar powered chemical dosing system in this trailer that you can see in the upper right. And so it's been successful here. And there's other sites that are similar to this that are now being looked at with the same similar approach, right, to use the existing channels and runoff basins with a chemical treatment approach to avoid the higher cost of a pump and treat type solution. And then this is a transfer station. So what's really interesting here, this is really the worst sort of set of regulations that needed to be met, which included nutrients as well as bacteria, right? So there's some coliform type bacteria that would run off from this transfer station. And so this is a multi-site solid waste type business. Their corporate environmental lead basically decided to use a consultant because of the complexity of this and the workload that already existed. Really needed that help to get this done. So that led to a treatability study that we conducted in our lab. And you can see there's 5 cups here in the lower right. So despite that initial stage, which seems to really make that water look clear in that first cup, there's a lot of nutrients, bacteria, dissolved compounds, et cetera, that have to be addressed there. And so, quite a challenging site, quite a complicated multi-barrier treatment approach, coagulation, pH adjustments, then your sedimentation, filtration process, both carbon and ion exchange to get those dissolved compounds out, and then as well as those nutrients, and then ultimately UV treatments to go after the bacteria that comes from this site to meet those discharge limits. And so after the treatability was completed, a preferred vendor was identified. They were asked, because of the complexity of this, to really prove it on site. So we did a pilot. The pilot you can see in that upper right photo was done with some temporary equipment just to verify the selection of the treatment process as well as the sizing of it. And now the system is moving into startup and permanent installation. There was a little bit of a challenge initially in that pilot, right, with the phosphorus. And so there was an adjustment made. That's why, sometimes when you get a very unique stormwater multi-barrier, it is really logical to pilot. It offsets the risk of starting up a system that doesn't quite work. You try it at a small scale, make sure it works, make some adjustments. So just one more way, sort of like buying insurance, right? If we run a pilot, there is a bit of a cost associated with that, but it really sets up that permanent system for success. So like buying a little miniature insurance policy. So there was a multi-barrier solution. It was adjusted with a little bit of different chemistry, a little bit of different ion exchange process. And then the final solution was delivered there. And you can see here the numerical success here. And so things are, much lower than your targets, which is good news. COD is a bit close. So that'll be one to keep an eye on. But generally speaking, very high reductions, very successful approach here. And then last but not least, right, this was a electric utility, kind of a unique approach here. They only had iron exceedance at this site. And so we met this customer at a trade show. They were investigating different solutions, right? So went to a trade show focused around stormwater, started, discussing with them there. They did use a consultant to, because it's a very large utility corporation, right? Kind of a unique and very specific procurement process. And so there's a lot of help provided by the consultants to navigate that procurement. There was a, a time sensitive situation. And so we were actually able to repurpose a rental asset that was used at temporary sites into a permanent solution in order to do a faster implementation of this project, and basically repurpose it into a long-term solution. So here you can see the results. You can see, prior to the treatment install, the iron levels would fluctuate, quite a bit. Sometimes under that limit of 2 milligrams per liter, but not very frequently. A lot of heartburn, right, for that industry, that utility. And so with that treatment, we're well under very consistently, and they've got that peace of mind there with this active treatment system. So with that, just a very quick plug for my business. I hope you've learned something here today, and we've got still another 15 minutes, so I can open that up for questions here after just a couple more slides. So yeah, water tectonics, we've been around since 1999. We've done about 1,200 different industrial treatment systems in our history: construction, stormwater, industrial process, water, wastewater, intake water, as well as stormwater. So a lot of experience, a lot of efficiency we've learned about building these systems. One of our foremost and initial businesses has always been this pump and treat approach to industrial stormwater system, very low risk of exceedance with this approach. And, we're technology agnostic. And so we just look at each stormwater, we test it in our lab, we figure out what is the best solution for this site, for this stormwater, take that through the implementation process. By doing that scientific study at the very beginning, it takes conservatism out of the sizing of the system because we've actually tested it in our lab. Plus, we have a lot of experience at different sites. We know what's going to work and implement that at a site. Again, on Tuesday, catch this other presentation if you're in this journey, right? This will be another great one to sort of look at these potential pitfalls and learn from others, learn from us as we've gone through these processes and have a better outcome for your site. Just a map of our success thus far in California, and would hope to connect with others here and see what help we can provide. So with that, I can open it up to questions. John?
Thank
Yeah,
you, Steve. Yeah, thank you. Very good. So we do have one question. Doug asked, have you done any work in the East Coast, Northeast or Southeast?
We have, Doug. Yeah, we've actually put systems, I think, in 35 states now, 5 provinces of Canada, and I think, is it 15 different countries globally? And so we are not picky about where we help folks with their water treatment challenges, and I'd love to see what I can do to help you wherever you are.
All right, great. And if any of you have a question for Steve, go ahead and either type it in the chat or unmute yourself. We got a small enough class, and ask. Steve, while maybe people are thinking of a question, I wanted to ask about nitrates. That's always been a challenge, and we've noticed that in some treatment applications, it seems like sometimes the treatment media almost is the source of the nitrates. What's been your experience with that?
Yeah, John, I think that is a good question. So I think that you can you can have certain types of media that can contribute unexpectedly certain things to a stormwater runoff. And so we typically use a glass product. So it's a crushed glass that is very inert, and we're confident that in a stormwater application, it won't contribute anything. Now, that's not to say though that over time, as you use a media filter, right, things can build up in there.
Right.
You can get balls of sticky compounds, right, that build up there, and then every now and then those are going to shed and head downstream into your effluents. I don't think we have had that happen to us directly,
Yeah.
but from a scientific treatment standpoint, it's definitely something that could happen. And that waste transfer site I showed, I think that was like the second to last site. They did have nutrients there. They had nitrates, they had phosphorus, and so it was too small of a site for a biological treatment approach. It would have been very cumbersome to operate, and so we had to look at some ion exchange approaches, right, that grab nutrients. Those are out there. They work well at small flow rates, but as you go to bigger flow rates, you really have to use biology to treat nutrients, and so you have beneficial bacteria, right, that do that treatment work for you, much like what happens in a municipal application. The challenge in stormwater then is, you grow your good bugs and they're happy, and then it stops raining, and then they don't have anything to eat, and so real challenges there with nutrients.
Right. Yeah. Yeah. We've seen that also maybe some biological growth in the media from nutrients maybe can free up some nitrates at times.
Yep.
But
yep.
Good.
And we found that the actively backflush media is the key there. So there's some like sort of passive media solutions where you layer different types of media, but there's no ability to backflush that. And so once stuff starts growing there, you're stuck with basically replacing that media. There's an OpEx there. Now, certainly your CapEx of that type of solution is much lower, but it's important to look at that over like 10 years and say, hey, is this life cycle cost actually better or worse?
Right. Well, any other questions? If so, go ahead and unmute yourself. And all right. Well, I want to thank you all for being a part of this very first workshop of the 2021 Stormwater Awareness Week. And let me turn my video back on. And again, we apologize for the technical difficulties. Our IT people discovered it was an update on Zoom that the people at Zoom didn't tell us about, but apparently that we're working on a fix. In your chat, before you hang up, if you're planning on attending the 11 o'clock program, in the chat, I put a link to it with the login credentials. Just use your Zoom app like you did for this one, put that in. So you might copy and paste that right now. It's in the chat if you're wanting to do the 11 o'clock. Also, another thing you might copy and paste in the chat is my email and my phone number. In case you're having technical difficulties, shoot me an email or a text. I may or may not be able to answer my phone depending on whether I'm participating in a workshop or not, but we'll make sure we get you out. And Steve, why don't you put in your contact information real quick into the chat?
Yeah, good idea.
So that people can copy and paste that and get a hold of you if they want to ask any questions one-on-one with you. While you're doing that, just the programs for the rest of the day, 11 o'clock, we have a workshop that the Tolley Group is holding on watersheds, and they do a phenomenal job. You won't want to miss this workshop. A lot of high energy. I think you'll really enjoy it. And then at 12:30 after lunch, or if you want to take a late lunch, my son Andrew is actually going to be talking about using video for education, for stormwater education. That's a big part of stormwater permits. And if you've seen any of his productions or some of our Stormwater Awareness Week productions, he'll be sharing some of that, which, by the way, don't miss the keynotes on that front page where you logged in. There's pre-recorded keynotes that you can watch where we're going back and we're reviewing the last 10 years, kind of giving you a behind the scenes look at the event over the last 10 years, but we're also taking some of our favorite workshops and focusing on those. So I think you'll really enjoy that. And then at 2 o'clock today, we have BMPs and SWIFTs that don't break the bank. And so I'm actually giving that workshop. So if you want to join me at 2 o'clock, and this is more construction oriented. And so if you're interested in that, I'd love to have you. All right. So again, thank you. Thank you for your patience. And we will be seeing you. Any other questions, though, before we sign off? All right, Steve, any last thoughts?
John, I just wanted to thank you for the opportunity to kick this off, right? I didn't know I was picking the very first time slot. I was given 2 choices and I said, I like Monday mornings, so let's do that. And I know there's an enormous amount of effort that you and your team are putting into this and doing it for the benefit of all. So thank you for what you're doing, and thank you for letting me be part of it.
Well, thank you, Steve. And by the way, I should mention, and I did in the chat, if you missed any part of this or you would like to forward this to a colleague, it's going to be recorded and it'll be on the same place where you logged in for this class. Where will the Zoom information be provided for the other classes today? Hopefully we have that fixed. If not, well, I'm also working with the programmers to see if they can be displayed right there on the website. So hopefully it is fixed, but you have my cell phone and my email there in the chat. If you haven't copied it, copy it real quick before we end this meeting. And if you're having any problems today, just send me a text or an email and I'll be happy to give that to you. So Steve, I look forward to your next one. And so, all right, everybody, thank you. We'll see you at the next workshop.
All right, thanks everybody for joining. Have a great day.